So the next one, I'd like to share with you how Spark is working. There are two ways of doing it. One is using the Spark shell, or one is using Google Colab. Google Colab will be just like Python. So actually you can run this Spark shell. So for example, now assuming you're in the command line, okay, so you need to cd to the correct directory. So cd correct directory, and then after that you run. Okay, so this PyScala is actually inside this directory, py.scala. So you can actually open up py.scala. What does it do is actually doing calculate a pi and trying to use a square and each quadrant. So how many square can you fit in? Okay, so of course the more you fit in, the more accurate it is. So the total is a 4 quadrant, so multiply by 4. So of course you start with lesser, so maybe 1000. Then you have a less accurate. So as we know that pi is 3.142 something, right? So this will be less accurate, but of course it's faster than. Okay. So now you want to run the program. So this is the py.scala. And to run the program, just spark shell /-i, then after that py.scala, and you can run it, and it should be able to calculate the pi for you. And the pi will be calculating. So this is quite, because we actually have very little square, so this is fast. Okay, so although it's fast, I pause for a while. It take about 1-2 minutes. So the pi is 3.125, not so accurate. Okay, so let's try a little bit more. Say for example, now we try another 20. Okay, so that will bring us to 100,000. So make it 1 million, make it bigger. Okay. So pi, this Scala, because it's actually distributed, so it's quite actually using the parallelized. And if you look at this parallelized, so it actually have multiple slices. So it's supposed to be much faster, okay? Because it can, but in this case, it's not the real case. The real case that you can use multiple computers. But currently I'm running on one computer, right? Just so this is just a demo. Okay. So now we run the game this in the Spark shell. So what we do is that we run the program again. So let me see. Okay. So this one. Okay, this is the one. So PyScale. Let me pause for a while. So after like 1 to 2 minutes, so you can see this is closer to 3.142, right? The one that we have. So it's better than the previous one. Let me see, the previous one is still there. So the previous one is 3.12 something, right? So actually there's an improvement. So this is one way to calculate this, one way to run the Spark. So you can read the notes. So this is the program. And this is some of the results that roughly, Okay, so the next way to do it is using Google Colab. So this is the Google Colab, and I'm going to run the identical Pi program. So I prepared a few more other than the Pi program, so you can just open the PySpark here. So this is a program that you need to just cut and paste into the Google Colab. And the first one will be the pi, and we are using about 1 million. So you can just cut the whole thing, Control C, you just Control V to the Google Colab, and you can just run it. So I'm going to pause for a while waiting. Okay, so after you run for a while, this one take about 2 minutes, and because it's in the cloud, And the answer is 3.138. 3.138. So you can actually try another program. So the next program I like to try is this. It's called sorting. So the target is 135724. So sorting is another issue because most of the sorting take some time. Okay, so we need to parallelize it. So you can just sort it, and again using Google Colab, and this is the Control V, and then you run it. So I'm going to pause for a while again while waiting for the results. Let me see. No. So the sorting is quite fast because there's only few numbers. So 1, 2, 3, 4, 5, 6, 4, 5, 1, 2, 3, 4, 5, 7. Okay. So the next one, this sorting from a file, so you can actually save it in a file. So in a sort file, sort.txt. So if you want to look at what is sort.txt, so this one, while we are waiting, so we can take a look at sort.txt here. So 135724. So you can do the same thing by opening a file, and then you actually can store from there, sort from there. So again, you have 1, 2, 3, 4, 5, 7. So actually extract data from this file. And the next one that I'd like to show you is probably the last one, which means the word count. So this is the word count. So you can Control C, Control V. Then you can run for the word count, and the word count will be here. So I'm going to school, I'm going to toilet. So you can see I probably 2 times, and 2 times, going 2 times, etc. So it's just doing a word count. And oh, that's fast. So you see here, I is 2 times, M is 2 times, school is once. So this is something that you can try out using this Scala, and the key function is called parallelized. Thank you for listening.